Hi, and welcome back. Today we're going to look at section 4.2, which is on the mean value theorem. So just adding a little bit more to what we did from section 4.1. So first off, we're going to look at a couple of theorems. So the first one is Rolle's theorem. Okay? And Rolle's theorem says that if you let f of x be a function such that f of x is continuous on a closed interval, and f of x is differentiable on that open interval, and the endpoints, okay, f of a and f of b, so these are the y values, are equal to one another, then if all of those things are true, then there has to be a number c between a and b such that the derivative of c equals 0. Okay? All right, so let's talk about kind of what all this means real quick. So first off, we know what a continuous function is, so we have to double check to make sure that our function is continuous on the interval they give us. Is the function differentiable? Everywhere except for the endpoints. We don't care about the endpoints, but everywhere in between. So remember, to be differentiable, that means there's no holes, no corners, no asymptotes, right? Nothing that we can't take the derivative of. And then we have to make sure that the endpoint values are the same. The y values are the same. Okay? So what does that mean? So if I look at quickly a picture of a graph, okay, and I pick an interval. So let's say here's A and here's B. Okay, just pick any two numbers, A and B. Then this, remember, the y values have to be the same. So let's say I just put a point here. So this would be f of a, right? Then over here, f of b would have to be the same at the same point, right? So this would be that f of a and f of b are the same. So they have the same y value. So they're horizontal to one another. Okay, so maybe now you can kind of see what this is saying. So if this is all true and I have a continuous function, then what happens to my function between a and b? Okay, several things could happen. One, it could just be a horizontal line connecting those, right? That's one thing that could happen. Two, I could have a function that increases and then comes back down here. Or I could have one that goes this way. Right? But again, a continuous function. So between these 2 points, it's continuous. And then the third thing that could happen is a lot of ups and downs. I could have a function that goes up and down and up and down and up and down. But it doesn't matter. It's still continuous. Okay? So any one of those things could happen. But no matter which of those things that happened, I can find at least one number c between here where the derivative is 0. So think about what that means. When would the derivative be 0? Okay, we know the derivative is 0 where there are max and mins or a horizontal line. So if my graph did this, then every point in between would have a derivative of 0. So there would be lots of c values in there. Let's take the example where it just went, maybe my graph goes like this. Well, there's still going to be at least one point where the derivative is 0, right? Where they have a horizontal line. And if I had the case where lots of things were going on, then I would find lots of values where the derivative is 0. Okay? All of those values are between a and b. So that's what this is saying. We can find at least one, maybe more, where the derivative is 0. But in order for that to happen, this has to be true, and we have to have a continuous differentiable function. Okay? So this is important when we're looking for roots, max and mins, different things like that. So that's an important theorem that we're going to be using from here on out. All right, the next theorem just as well, the mean value theorem. This is an important theorem, but a lot of students forget what it's telling you to do. So you got to really write this down, make sure you remember about the mean value theorem. So the mean value theorem says if x is a function and it's continuous on that interval a to b, and it's differentiable, so kind of like Rolle's theorem was, then there is a number c in that interval. Now this is where it's different, such that the derivative of c equals this. What is f of b minus f of a over b minus a? Okay, hopefully this looks familiar to you, but this is the formula to find the slope, right? These are the y values, y2 minus y1, and these are the x values, x2 minus x1. Remember, a and b are your x values, your interval. So this is just the formula for slope. So what this theorem says is that we have an interval from a to b, and notice on this one, f of a does not have to equal f of b. In this one we have a picture. So here's a and b, here's point A, here's point B. They're not equal to one another. Okay, and it doesn't matter because what this says is if I can find the slope of the endpoint line, okay, then I can find at least one more place on the curve that has that exact same slope, okay? So notice these two lines are parallel. So again, this theorem says if I can find the slope of the endpoints, so the slope of these points from A to B, find the slope, then there is a point C such that the derivative of C will equal that. So I'm going to box this in because this is real important. Now what happened over here is they just took the b minus a and they multiplied it over here. So they just got rid of this fraction and took b minus a and multiplied it to f prime of c. Right here, f prime of c times that. Okay, so they just they just took the denominator and brought it over here. So that's just another form of that. This is more important to me that you guys understand that it's the slope. Okay? All right, so mean value theorem has to do with the slope. Okay, and I'm going to put slope of the endpoint. So that's the difference. Most everything else we do with calculus and with the derivative, we set it equal to 0. Okay, not the mean value theorem. The mean value theorem says take the derivative, set it equal to the slope of the endpoints. Okay? So it's not a hard problem. It's just sometimes we forget to do that. Okay. Then you have a couple of quick theorems. One is the constant theorem and one is a corollary. These are kind of just, I mean, you kind of can think about this. We don't use them a whole lot. It's just that, you know, they're there and just for you to think about. So this says if the derivative of x equals 0 for all x on the interval, for all of the x, okay, then f of x is constant on a and b, okay? So again, if the derivative everywhere is 0, that means that the line or the function would have to be a constant function because all of these derivatives are 0. Okay, so that's a constant function, so that's all that's telling you. And then the corollary to that says if you have two derivatives of two different functions that are equal for all the x's within the interval, then if you take the two functions and subtract them, you're going to end up with just the constant. Okay, so think about it. If the derivatives are equal, so let's look at those lines again. Let's say here's function f and here's function g. They would have the same derivative, right? They would have the same derivative, whatever it might be. So if we took these two constants, okay, and subtracted them, we would if we took these two functions and subtracted them, we would end up with just a constant. So let's just make one up. Let's say this is f of x equals 2x plus 5. And let's say g of x is 2x minus 1. Okay? So remember, the derivatives are the same, which means the slopes have to be the same. So if you take this minus this, the two x's are going to cancel out and you'll end up with 5 minus negative 1 or 6. It doesn't really matter what the number is. It's just telling you that you're going to end up with a constant. Okay? You're going to end up with some constant c. All right, so those are the 4 theorems for today. So hopefully you watched the intro video. Number 1 just takes you through the 3 reasons that make Rolle's theorem valid. So that's what we're doing. So we're going to do another one of those in a minute. Number 2 talks to you about the mean value theorem and using the slope. We're going to do one of those again. Okay. so let's look at number 3. Okay, so this again, we're going to use Rolle's theorem. So consider the function f of x equals x squared minus 4x plus 1 on the interval between 0 and 4. Verify that this function satisfies the 3 hypotheses of Rolle's theorem, and then once you verify those, then find c. Okay? All right, so remember the 3 things that has to be true for Rolle's theorem. Okay, the first thing is that f of x has to be continuous. Well, that's a polynomial. All polynomials are continuous. So that's just, you know that. Okay? So the first thing you have to check is it continuous on this interval? And yes, this is continuous from negative infinity to infinity. So definitely from here to here. All right, the next thing is it differentiable? That's, again, a continuous function. It has no asymptotes, no corners, okay? It's a curve, it's a parabola. So this is definitely differentiable. Okay, so that's the next thing you got to check. Can you differentiate it? Yes, you can. And then last, the endpoints, f of 0 and f of 4 have to have the same y value. Okay? All right, so if we plug f of 0 in here, 0 squared is 0 minus 4 times 0, 0. 0 minus 0 plus 1 is 1. Okay? F of 4. 4 squared is 16. Minus 4 times 4 is 16. So we've got 16 minus 16, which is 0, plus 1 is 1. So I think that line was supposed to be the 1 there. Okay, but both of f of 0 and f of 4 are the same value. They both equal 1. All right, so if all that is true, then I can find a value c such that the derivative equals 0. Okay, this is 0, Rolle's theorem. All right, so all I have to do is find the derivative, which is 2x minus 4. Okay, set that equal to 0 and solve it. So 2x equals 4, x equals 2. And notice that 2 is between 0 and 4. So c, the value of c that I want is 2. It's just the x value that makes your derivative equal 0. Okay? So that's the value that we found. Remember, this is f prime of x. We're just substituting in c for that. All right, number 4, mean value theorem. So we have a function, again, a parabola, which is continuous, definitely continuous on -3 to 6. Find the average mean, find the average or the mean slope of this function. So that means find the slope of the endpoints. And then, using that slope by the mean value theorem, I know that I can set the derivative of this function equal to this slope value and find another value that equals that. Okay? All right, so I'm going to come up here. I have to find f of -3 and f of 6. Okay? So I need to find the y values. I need ordered pairs so that I can find the slope. Okay? So I'm going to plug in -3 here. Okay? So 3 times -3 squared. All right, well, -3 squared is +9. 9 times 3 is 27. 27 plus 5 times -3, so this is going to be a -15. So 27 minus 15, okay, plus 11. So that's going to give you 23. You work that out. All right, and then we're going to plug in 6. Okay, 6 squared is 36. 36 times 3. And then you've got 5 times 6, which is 30, and plus 11. So you're going to work all that out. Plugging 6 in there, you end up with 149. All right, so now your ordered pairs are -3, 23, and 6, 149. So this is just basic algebra. When you're asked about the mean value theorem, that always means find the slope of the endpoints, always. Okay, so in order to do that, typically you're only going to get the x coordinate, so you have to find the y values. All right, so now that I have that, I can plug in. Remember, these are your y values. So what was f of 6? That was 149. Minus f of -3 was 23. And then I already have 6 minus -3 down here. Those are my x values. So 149 minus 23 is 126. 6 minus negative 3 is 9. Divide that out. 9 goes into 126 14 times. So that's the slope, okay? That's m. That's the slope of the endpoints. All right, so now it says, by the mean value theorem, we know that there exists some c in between those two numbers, so another x value, such that the derivative of c equals the slope, this guy. All right, so now we're going to find, so this is just like what we did, except you're going to find the derivative, 6x plus 5, and you're not going to set it equal to 0. Mean value theorem says set it equal to the slope. So I'm going to set it equal to 14. And then I just solve that. So 6x equals 9. Divide both sides by 6, we get 9 over 6, which is 3/2. Or you can write 1.5, right? Same number, but notice, is that between these guys? Yes, it is. So that's the value of c that we found, 1.5 or 3/2. Okay. That is the derivative of the function equal to the slope. That's the x value, which is, again, c for this problem. Okay? All right. Number 5. This one is kind of a weird problem. I'm pretty sure it's on Webworks, so let's just kind of talk about what this means. This says, by applying Rolle's theorem, check whether it's possible that the function f of x equals x to the 5th plus x minus 11 has 2 real roots. All right, well, for it to have 2 real roots, okay, using Rolle's theorem, remember that means that the endpoints, those roots have to equal the same thing, okay? So let's take a look at what this is asking you about. And by the way, what does that mean when you're having real roots? That means that's a critical number, right? It's where the derivative equals 0. All right, so let's talk about, well, I take that back. This doesn't mean that you have a critical number. That means you would have at least one critical number, right? So let me kind of draw that out for you. If you have 2 roots and you have a polynomial, then between those 2 roots, this function has to have a max or a min somewhere, right? It has to come up or down so that it can go through the axis twice here. So we have to have at least one critical number, if not more than one, okay? So that's kind of what we're going to look at here. Now, at the bottom here, it says, is this possible or impossible? So all of this is part of number 5. This is the way Webworks is asking you to do that. All right, well, so if that's true, and I find the derivative, which is 5x to the 4th plus 1, okay? This is a function that's always positive, right? Look at your answers. You take any number and raise it to the 4th power, it's positive. Multiply by 5 is positive. Add 1, it's positive. Okay? So there is no way that this can ever equal 0. Okay? If you set this equal to 0 and try to solve it, you can't. We can continue if you don't believe what I just said. But if we try to solve this, I can't take the 4th root of something negative. It doesn't exist. So these numbers, okay, these values are always positive. And that's the derivative. And if the derivative is always positive, that means this function is always increasing, right? Remember, that's what that means. So if I were to graph this function, it wouldn't do this. It might cross the x-axis once, but it's going to keep going up and up and up. So there is no possible way for this function to have 2 real roots because of the derivative. Derivative would have to be able to take positive and negative numbers, and it can't. Everything you put in for x right here will be positive, okay? And remember, derivatives that are always positive means the original function is always increasing. So this can't happen, okay? So we just disprove that. So down here, it asks you, is it possible or impossible? I would say it's impossible. And now you're going to be asked to fill this in. So this is what's kind of weird. So I'll help you with this. It says your reason is that f of x has 2 row roots by Rolle's theorem means that the derivative must be what? Must be 0 at certain values of x between these 2 roots. Right? We must have a derivative of 0. That's what this is saying. However, since the derivative is always positive, and then it just stops, which is kind of weird, but since the derivative is always positive, then this cannot happen. Okay, so this is kind of just a weird setup on Webworks, but more importantly, this is what I really would like you to know, is that when we start doing curve sketching coming up in the next few sections, this is important because knowing that the derivative is always positive will mean I don't have any max or mins. It means this thing is always increasing. Okay. All right. So it's kind of a roundabout way to answer that question, but it's a good question. So are you really using Rolle's theorem? Well, remember, Rolle's theorem says that the endpoints have to be the same, and that's what this was trying to get at. We couldn't even get the endpoints to be the same, the roots. So we kind of used it in a roundabout way. All right, lastly, okay, number 6. Suppose f of x is continuous on the interval 2 to 8, and the derivative of x is between 2 and 8. That doesn't always have to be true, okay? But in this case, they're giving you the same numbers. Sometimes these intervals will be different, so just kind of pay attention to that. Use the mean value theorem to estimate f of 8 minus f of 2. And then again, this is Webworks. And so what they want you to do is give the 2 values that the y values, when you subtract them, have to be between. Okay, so we're giving an estimate between what and what. So remember, these are the y values. Okay, f of 8 minus f of 2. All right, so I'm going to grab our first page, and I'm going to write this down because this is the mean value theorem. So I'm going to write this down on my paper just so you can kind of see what I'm doing. Okay, so this is what I'm getting ready to write. So we know that the mean value theorem says that the derivative of c has to equal the slope. Right? Okay. So mean value theorem, that's what this is. The derivative of c, and remember we're doing x in a minute, but this is the formula. Okay, so let's substitute in what we have. So we're going to do f prime of x. And then what are these numbers? These are my x values. So f of 8 minus f of 2, right? That's the y values. And then 8 minus 2 in the bottom. All right, so think about it. I don't know y, but I know I can say f of 2 is the y value for that function, and f of 8 is the y value for that x value. Okay, so y2 minus y1 over x2 minus x1. So remember, this is your a and b, right? That's the interval. Okay, so that's where I'm getting a and b. Those are my values. All right, so we can simplify the bottom. F of 8 minus f of 2 over 8 minus 2 is just 6, right? So I just subtracted that. All right, so what did it tell you that the derivative was between? It says the derivative is between 2 and 8. All right, so look at what I have. Here's the derivative. So in place of f prime of x, I'm going to put this. Okay, so in place of here, I'm going to put this. So 2 is less than or equal to this. Okay, so I placed this with what it was equal to, and that's just the slope formula. All right, So last thing I have to do is solve for f of 8 minus f of 2. I already have that. All I got to do is get rid of this 6 in the bottom. So how do I get rid of the 6? I'm going to multiply it to both of these numbers. So 2 times 6 is 12. And 8 times 6 is 48. Okay, so there's my two numbers that it wants. It wants 12 here and 48 there. So when you guys do that in Webworks, that's what it's going to ask you for. I think it asks you for A and B. Okay. All right, so that's just by definition. Okay, so this looks a little weird, but that's all that this is just saying if you understand your function notation and that these are x and y values. Okay. All right, so that does it for section 4.2, not much in there. So work on your notes check, work on your homework. Let me know if you have any questions.